Hello and welcome to this video. In our previous video, we talked about the introduction to Matlab programming. In this video, we'll talk about the flow of control in Matlab programming language. Now, when you run a code in Matlab, each statement is executed in the order in which they appear. For example, consider this code below here, where we have z is given as x plus y, where x is given as 5 and y as 7. Now, when we run this code, Matlab will give an error. If we run this code, we'll get an error message that unrecognized function or variable x. Although we can see that x is defined here as to have a value of 5, Matlab does not see that value. So the reason for this is that x is encountered before it is defined. X is being used here. Z is equals to x plus y. So x is being used before it can be defined. Let me change the view of this so that it is clear what is happening. Matlab learns this line before the value of x can be obtained. So it gets an error with this line. So if we want to correct this error, we simply have to define the values of x and y, to define the variables x and y before we can use them. Because Matlab will learn and encounter the line z is equals to x plus y, it is trying to add the values of x and y, but at this point, the values x and y have no values. They do not appear in the workspace. So if we want to correct this error, the variables x and y need to be defined before they can be used. That is, we simply change the order in which the statements occur. So x is equals to 5, y is equals to 7, and then z is defined as x plus y. So when I run this one, I should get the value now of z is equals to 12. Now, programming languages like Matlab can let you change the order in which the code executes, and this allows you to skip some statements or learn certain statements over and over again. Now, programming constructs that lets you alter the order in which the code executes are known as control flow statement. The flow of control in Matlab is achieved through constructs such as the conditional statements. These are statements like if, else if, and switch. Another way they can be achieved is using the loops such as the for loop and while loops, and also the function calls. These tools enable developers to design programs that respond dynamically to varying inputs, adapt to changing conditions, and perform repetitive tasks with ease. Understanding how to use these flow control structures in Matlab is important for creating codes that is not only logically sound but also efficient in solving complex problems. Let's look at the conditional statements. And we start with if, else, and else if statement. Now, the if statement normally checks whether some logical expression evaluates to true or whether it evaluates false, and then we'll execute the block of code when the expression is true. Whenever the expression evaluates to false, the code will exit. So in Matlab, an if statement starts with the word if, and this is followed by a logical expression. For example, we can have a code like this. We define the value of x to be 9, the variable y to have a value of 11, and then we have the if condition. If x is greater than y, display x is greater than y. So what does this code, what will this code do? First, we have assigned the values to x and y. So the if statement is followed by the conditional the logical expression here, x greater than y. So this one will simply check whether this condition is true. Is x greater than y? If x is greater than y, then Matlab will display that x is greater than y. If that is not the case, if x is not greater than y, that is, if this statement evaluates to false, then the loop will just exit the condition. Matlab will just exit without displaying anything. So here, x is 9, y is 11. We know that x is not greater than y. So when we run, there will be no output. But if I change this maybe to 5, or rather 5, y is 5, x is 9. Now y is less than x, so x is greater than y is actually true. So when I run, I should see an output. X is greater than y. X is greater than y. X is greater than y. But if this is put to 11, so the condition will evaluate to false, and there will be no output. So when we run this code, the if statement will check whether x is greater than y. And in this particular case, because x is less than y, the expression evaluates to false, and there will be no output. So we may, however, add some few more lines of code to make our program more responsive. We have the first condition: if x is greater than y, display x is greater than y. And else, if x is equals to y, equals checks whether the two variables have the same value. If they have the same value, this will display x and y are equal. Else, if the first condition is false, the second condition evaluates to false, then the last condition should execute. So what this happen when you run this one, what will happen is that the first condition will be checked, and if this evaluates to false, this line will the Matlab will skip this line and move to the next condition. Check whether this condition evaluates to true or false. If it evaluates to true, this line will display, and if it executes to false, it will skip this line and move to the next one. Since there is no condition here, to just display the output. Now here, x is less than y. So we know that the first condition is false, the second condition is false. So we expect the last statement when we run. So when we run that, we get x is less than y. But if I write x is 9 here, so I expect the second condition here to display x and y are equal. So that is how the if statement works. Then we have the switch case statement. So the switch control in Matlab is a control flow statement that allows you to execute different code blocks based on the value of a given expression. It provides an alternative to the use of multiple if-else statements when you have a large possible cases to consider. The syntax is as shown here. We have switch, then expression to check. The expression here is what to check whether the condition evaluates to true or false. And the cases will execute depending on the expression that you have indicated here in the expression. Let's do an example. Suppose we have the case where we want to do the grading of marks, for example. The grading is defined in such a way that a person who scores 70 and above will get grade A, A person who scores a marks between 60 and 69 will score grade B. A person who scores 50 and between 50 and 59 scores grade C. 40 to 49 is D, and below 40 is E. So if we want to write a program that can display this, then we can use the switch. So we enter the mark, for example, X is 42. Then we have switch. The condition here, we can just write true. So this means that if the condition, any condition here executes to true, then we get the output. So if the first case here is the logical expression to check is whether X is greater than or equals to 70. If that is true, then this line executes, and the display will be grade A. If this is not true, then this line will be skipped, and the next condition will be checked whether X is greater than or equals to 60 and less than 70. If this condition is true, then this one will display grade B. If that is not true, then it will skip that and move to the next case, and so on and so on. So like this, in this particular example, 42 is between 40 and 49, is greater than 40 and less than 50. So we expect that the output is grade D. So when I run this one, I should expect to see grade D. Notice that here I've written true. If I shift this to false, it will mean that when the condition specified here, when the logical expression evaluates to false, then this one is displayed. So this will mean if I enter a value 42, then the first condition will check is X greater than or equals to 70. This will evaluate to false, and because I've indicated that the switch here displays or executes whenever the logical expression evaluates to false, then this will output grade A. So grade A. So that is not what we want. We want this to output when it is true. Then we have the loops. So we have the for loop. So for loops are programming constructs that let you go through each item in a sequence and then perform some operations on each item. For example, we could use the for loop to find the sum of the first 100 positive integers. If we want to find the sum of numbers from 1 to 100, we can write for k is equals to 100. For k is equals to 1 to 100, that will generate a series with numbers 1, 2, 3, 4 up to 100. Then we have set s to 0, and then we write s is equals to s plus k, then print the output. What this will do is that the value of k will be set to 1, and then s will be computed as s is equals to s, the previous value of s, which is 0, plus the value of k, which is 1. So s will have a value of 1. Then the value of k increases to 2, the next item in the sequence. And now s is computed as the previous value of s, which is 1, plus the new value of k, which is 2. So 1 plus 2 is 3. Then the value of k increases to 3, the next value in the list. So s is computed now as 3 plus 3, which is 6. And so this will repeat until the last value of k, which is 100, which means that to add the sum of the first 100 positive integers, the sum of integers from 1 to 100. So when I run that, I should expect the sum of the first 100 integers. Now, a for loop will iterate through a for loop, as we have said, will iterate through all numbers in a sequence. However, there are some special cases or some special keyword that can be used to control the for loop to allow you to skip some numbers in a sequence. There may be cases when you don't want to iterate through all the numbers in a certain interval or in a certain sequence. There are some keywords that can help you skip some of those numbers. These keywords are the continue and the break. Now, the continue keyword causes the for loop to skip the current iteration and go to the next one. So, for example, consider this code here. We have s is equals to 0. It's just like the previous one. S is 0, then for k is equals to 100. If k is greater than 50, continue, add, then s is equals to s plus k. What this one will do is that it will iterate through the sequence from 1 to 100 as before, but if the value of k is found to be greater than 50, then that value will not be added to the series here, to the sum here. So it will skip. Matlab will skip that value and go to the next one. So in this case, Matlab will add the first 50 integers, the sum of integers from 1 to 50. And then when k is 51, then this one will evaluate to true. And then that value will be skipped. So what we have here, we'll expect to get the sum of the first 50 integers, the sum of numbers from 1 to 50, and not from 1 to 100 as before. So when we run this, we see that the statement will check whether k is greater than 50, and if this one evaluates to true, then the loop will skip the iteration and move to the next value of k. So the loop will only execute when the if statement evaluates to a false, that is, when k is less than or equals to 50. So that this loop here will give us the sum of integers from 1 to 50. We can confirm this by doing a sum 1 to 50, and we see the sum is 1275, as we have here. We have the break keyword. The break keyword halts the execution for a for loop entirely. So in this case, the for loop will exit and the program continues to the code coming after the for loop. So unlike in the continue keyword, where the for loop will just skip the current iteration, the break keyword will cause the for loop to exit. So in this case, when we run like this one, we see that this one is just like the previous one, but here we have the keyword break. So it should do exactly, it should just give us the same sum as before. But what this does is that when this value executes to false, when k is greater than 50, that is, when the logical condition here becomes false, or becomes true rather, when the condition here becomes true, the loop will exit. So it will not continue checking, like in the case of the continue. In the case of, if we had continue here, the loop would continue checking until the last value of k, which is 100. But this one will not continue. The moment a value 51 is encountered, the loop will exit. The break keyword will cause the loop to exit and print the outcome. So when we run, we should get this. We get the same results as before. But that does not mean that this loop is doing exactly the same thing as the other one. They are not doing exactly the same thing, because in the case of the continue keyword, when a value like k is 51 is encountered, the loop skips that value, then moves to the next value of k, which is 52, checks whether it is greater than 50, and then finds that this one is true also, and skips that one and goes to k is equals to 53, and so on until k is equals to 100. But this one does not check whether for the values of k after one value, and after the value of k of 51 is encountered. So this means that the break keyword will execute much faster than the continue keyword. Because while the continue keyword will continue checking the other values of k, the break keyword will just cause the loop to exit and print the outcome. So when the continue is continuing to check other values of k, the break keyword will have caused the loop to print the output. So this one will execute faster than the continue keyword. Now, we have the second kind of loop, which is the while loop. While loop are similar to a for loop in that they allow you to execute a code repeatedly. For loops execute a code a specified number of times, which is equals to the length of the sequence being looped over. In this case, the programmer knows the required number of iterations in advance. While loops, on the other hand, keep executing until a specified condition becomes false. So in this particular case, when using the while loop, the programmer may not know exactly the number of iterations that are required to obtain the required solution to the problem, but the programmer may know the condition that must be satisfied for the solution to have been obtained. So you specify the condition and let the loop iterate until that condition is satisfied. So in this case, the programmer specifies the condition, that is the logical expression, such that the code executes until the logical statement executes to a false. So consider a code like this one, a simple one that does exactly the same as the one previously, that is adding the numbers. We say k is 1, s is equals to 0. Then while k is less than or equals to 100, s is equals to s plus k, k is equals to k plus 1, and this one will just be increasing the value of k by 1, this statement here. So that k starts with a value of 1, then this one increases by 1 to 2, then by another 1 to 3, then by another 1 to 4, and so on, until k becomes 100. So what this does is that to be adding the sum, to just get the sum of the first 100 integers as before. But here we have not specified the series. We have simply specified a condition that must be satisfied for the loop to execute. So when this condition evaluates to false, the loop will exit. That is, when k becomes 101, the loop will exit without executing. So that this code will still give the sum of the first 100 in positive integers. So the code will keep executing as long as k is less than or equals to 100. When k attains a value of 101, the expression k less than or equals to 100 would execute false, and the loop will exit and print the output. Note that the if condition, note that this condition, the while loop, if the condition specified remains true, the loop may iterate the infinite number of times. Such a loop is likely to cause the crash of the program. So it is important that before you run, you ensure that you have your loop, your condition, this condition that you have specified here should become false at some point. Otherwise, if it will remain true for all values, then the code will keep executing. So if we don't have this statement, for example, if we were to remove this statement, k is equals to k plus 1, k will remain with the value 1, so that each time k will be 1 and 1 is less than 100. So this condition will remain valid, will remain true each time, and therefore this loop will iterate forever. And such a loop will cause the program to crash. So you must be very, very careful here with when you're using the while loop. The condition specified here must become false at some point, or you must have a way of exiting the loop if the condition fails to become false. Now the continue and the break keywords works inside the while loop in a similar way as for the for loop. For example, we can write k is equals to 1, SB is 0. So while k is less than or equals to 100, if k is greater than 50, break. Then we have the sum. This should give us the sum of the 50 integers, numbers 1 to 50. We can have the continue keyword also working in the same way, and this again should give us the sum of the 50 integers. So we can have the continue and the break keywords inside the while loop. If we want to skip some values in the, we are interested in skipping some values, we can specify the condition for the values that we don't want to use and use the break or the continue keyword depending on which one we may want to use. So basically these are the flow of control statements. As we have seen, we have the conditional statements such as the if, else, and else if, and we also have the switch case statements. Then we have the loops where we have the for loops and the while loops. So thank you for watching, and we shall meet again in the next video.